Welcome back to Math Marbles. We have another area lesson for you today. Today we're going to calculate area using addition or multiplication. All right, so as I model for today, I want you to look to see how we write expressions. And we can write them in different ways. They're not always going to be very easy. They're going to look different sometimes. And I want you to think about how I accurately calculate the area of rectangles. Let's jump into our first example. Which expression cannot be used to find the area? So before we get distracted, let's just close these up. Let's not look at it for a second. And let's just look at our shape here and think of all the ways we could find the area. And luckily we can see the tiling. We can see each one is out of 1. So very good. So if you wanted to, you could just count all the way down. But I want to write an expression. An expression is not counting. So I could, let's write our dimensions again. I see 3 tiles this way, and 1, 2, 3, 4, 5, 6, 7. And there's 7 rows. So I have 7 rows of 3. So I could count by 3s this way, 3, 6, 9, 12. So I can count by 3s. And I could repeatedly do this. So I have 7 3s, 1, 2, 3, 4, 5, 6, 7. So I could just repeatedly add 3s. Or I could add 7s. I have 3 groups of 7s. So those are my 2 addition sentences. So I can have 7 groups of 3s if I think about it horizontally, or I can count vertically and see 3 groups of 7. Or I can use multiplication and see this as 7 times 3. So that's another way I can express this. So let's look at our choices, because we're not looking for the correct ones, we're looking for one that cannot be used. So let's look at the first one. And the first one has, let's see, how many 3s there? So it looks just like this over here. 1, 2, 3, 4, 5, 6, 7. Valid. So that one works. Our second one is repeatedly adding by 7s, 3 groups of 7, just like we had here. So that one is also true. So we're looking for the one that cannot be true. Ooh, 3 plus 7 plus 3 plus 7 plus 3. Yeah, this one doesn't work because I'm just randomly adding. That's like saying adding 3 and then adding 7 and then adding 3 and 7. That does not work. So this one cannot be used. Okay, let me just erase that for a second. And our last one's probably our multiplication, 3 times 7, which is another valid way. So that's one kind of question you might see today if you're using our Math Mini Lessons handout for today. You might be asked to find an expression that cannot be used to find the area. Or they might ask you, can you make an expression that can be used? So be ready for both and read carefully. Hit pause and jot this down into your notes. Here's our second model. Kelly has a rectangular poster in her room. The poster is shown below, well actually it's shown here. What is the area in square feet of her poster? So this one does not have tiling. I don't want to look at these yet because they can be very distracting. So how can we imagine our tiles? What does this tell us? Well, we have the dimensions here, and this too tells us that I have 2 rows, and this 3 tells me I have 3 columns. That really helps me. So these dimensions, it could say I have 2 rows of 3, and I could represent that as 2 times 3 to get 6. So let's see which one shows that answer. Nope, 5, that's not correct. There it is. B that's my area. I have 6 square feet. The other one was 10. Nope, that I don't have 10 tiles, and the other one would have been 12 tiles. So notice here, I can use my dimensions to figure out the number of tiles by multiplying them. I can find the area by multiplying these 2 dimensions. So area is equal to the product of my length and width. So that's one way of finding it. All right, hit pause and jot this down into your notes. You are going to have problems like this that do not have the tiles, but they will give you the dimensions, and this is how you can find the area. All right, and here's your guided practice. Which shape has the greater area? So which one is covered by more tiles or has more tiles in it? Be sure to include the area in square feet in your answer and explain. Hit pause and get to work. All right, so which one has the greater area? Let's calculate this one. And we can see the tiling, but I'm also going to write instead of using addition, I'm going to use my multiplication sentence. So for the first one, my area is equal to 14 times 2. That's how I can find out the total number of tiles. So the area is 28 square units. So that's my area for rectangle 1. For rectangle 2, my dimensions are 7 and 9. So I can multiply those. 7 times 9 is 63 square units. So this one has the greater area. And that kind of makes sense because you can just see it has way more tiles than the other one. So you should have chosen rectangle 2 has the greater area. And as you're writing your answer, you should have some evidence in there. So one, we're looking for, did you show your work, how you calculated the areas? That's the first thing they're going to look for. And then the second one is how somehow justifying your answer. So explaining it. So here's an example that I would write. Let's see. Instead of saying the rectangle 2 has the greater area. The area of rectangle 1 is 28 square units. Rectangle 2 has an area of 63 square units. 63 is greater than 28 square units. And done. Like, notice I don't have to explain more because my work is also here to show how I got those numbers. And that's a lot of times what teachers are looking for. How did you get those numbers? As if you guessed. We know you didn't guess, but so keep that thinking visible on the page. All right, that's it for today's lesson. I will see you in the next one, Math Marvels. Just if anything, just keep thinking about how you're representing the area in your work. That's it for today. Bye-bye.